PV inverters connection, Modbus RTU, serial. In this video, we will demonstrate how to connect the ePower control to PV inverters using a serial connection. The video is divided into 5 sections. Required materials: connecting the PV inverter to the controller, adding the PV inverter to eConf, testing the communication with the PV inverter. Part 1. Required materials. Elms device and the PV inverters are communicating in Modbus RTU. For this, we will need Elms device is connected to the switch via LAN port 1. Shielded twisted pair cable. Termination resistors with impedance matching the communication cable, typically 120 ohms. Flathead screwdriver. Bootlace ferrules. Wire stripper. Crimping tool. Laptop. USB to RJ45 adapter if your laptop does not have a LAN port. RJ45 to RJ45 Ethernet cable. Part 2. Connecting the PV inverter to Elms controller. Before connecting the PV inverter, make sure to set a unique slave ID on the RS485 network, 1 to 247. Configure the baud rate. Set the parity. Adjust the stop bit. Enable dynamic power control. The PV inverter can be connected to one of the serial ports of Elm device. Multiple devices can be connected to the same port. The serial ports are located at the bottom of Elm's device. Use a flathead screwdriver to unscrew terminal connectors 1 or 2 for easier cable wiring. Gently pull on the terminal block to remove it. Grab the twisted pair cable and identify the color code based on the manufacturer's manual. In our case, we will use the brown wire for data B, positive, the white wire for data B, negative, the yellow wire for ground. Try to organize the wires for better handling. Use the wire stripper to remove the insulation from the wires. It is recommended to use bootlace ferrules as they provide a more reliable and secure connection by preventing fraying and ensuring proper contact. Ensure you fit bootlace ferrules on the ends of the positive and negative wires. Connect the shielded wire to the ground wire by twisting them together, only on the controller side. Ensure you fit bootlace ferrules on the ends of all the twisted pair wires. Grab the terminal block and connect the brown at the pin 3 data B, positive, the white at the pin 4 data B, negative. Grab the terminal resistor and place it between pins 3 and 4. After properly connecting all the cables, reconnect the terminal block to Elm's device. Once the terminal block is properly inserted in place, use a flathead screwdriver to tighten the end screws of the block. To connect multiple devices to the same serial port, follow the steps and diagrams shown below. Note that some devices may not have ground ports. In such cases, only connect the data pins as described. Connect your laptop to the LAN port 2 of Elm's device. Access the settings from your laptop. Go to Network and Internet Settings. Go to Change Adapter Settings. Right-click on Connection to the local network. Select Properties. Click on Internet Protocol version 4, TCP/IPv4. Select Properties. Select Obtain an IP address automatically to enable automatic IP address allocation. Or select Use the following IP address for manual IP address assignment and enter the settings as shown in the next window. A small TCP/IP window will appear. Click on Yes. Click on OK to save configuration. Open your preferred browser and log into eConf by entering the following IP address: 192.168.4.127. Enter your password to log into eConf and click Sign In to connect. On the left sidebar, click on Network. Click on Configure a new connection. And in the interface menu, choose Serial 1. In this list, select the serial where you physically connected the PV inverter. Select the appropriate operational network communication mode. Select the appropriate baud rate, which must be identical to the one set on the PV inverter. Select the appropriate parity, which must be identical to the one set on the PV inverter. Select the appropriate byte size which must be identical to the one set on the PV inverter. Select the appropriate stop bits. Click on OK to save the settings. Part 4. Adding the PV inverter to eConf. In the column specific to the Serial 1 connection, click on Add Device. Enter the device name. Select the PV inverter's vendor from the drop-down list. Select the reference of the PV inverter from the vendor-specific drop-down list. Select the Modbus RTU, protocol for communication between LM's device and the PV inverter. Enter the slave ID assigned to the PV inverter. Configure the response timeout and byte timeout. The interframe delay is set to 10 by default. Click on OK to save the settings. Part 5. Testing the communication with the PV inverter. To test the connection between LM's device and the PV inverter, first check the communication status by clicking on the 3 dots next to the name of the PV inverter you added. Click on Test. If your PV inverter is not connected, this window will appear with the Not Connected red indicator. Follow the provided troubleshooting instructions to help resolve the communication issues. Another way to test all devices connected to the same port in a daisy chain is by clicking the refresh icon next to the configured port Serial 1. This will display the status of those devices, and you can expand the window by clicking on the device name. eConf provides a few troubleshooting instructions to help resolve communication issues. Once all these steps are completed, communication should be established. As a second step of connection testing, let's verify the data acquisition. Navigate to All Devices from the left sidebar. Click on the recently added PV inverter. The page displays all the data that the controller will read from the PV inverter. Cross-check all the read values with those displayed on the PV inverter itself, if applicable. Please feel free to contact LM support or your sales managers. Eager to see you in our next training session.